for everybody's time coming to GPT and share what we thinking about silicon carbide industry and thinking about what going to happen in the next couple of years in such uncertain situations. 非常感谢大家花了这么宝贵的时间能够来我们公司大家一起分享一下接下来几年对碳化硅行业在这样一个不确定的一个经济形势下，大家来看看我们这些应该对明年对未来几年的一些想法吧。那么从碳化硅这样的一个行业来说的话，我们尽快的因为我在座大家都相对比较熟悉了，就尽快的过一下。That's the whole trend and key points of the silicon carbide industry, from material to epi to device making and NAND package to in applications. That's almost the same industry trend as for whole semiconductor. The key is that's the innovation from the very bottom, of the material. So we always call this industry as new material semi-industry. I always believe the silicon carbide probably is the industry which challenge the whole human boundary. The key is just because silicon carbide is so difficult material. The difficult is because silicon and carbide are both so cheap, and silicon carbide has become so difficult material. 从我的观点来讲的话，反正碳化硅确实有可能从我们的这样的一个工业化的角度来讲的话，从我们自己技术发展的历史上来看的话，应该是一个最突出的一个领域吧。就是这个突出的领域，就是它在工业化上的难度，可能它是确实在挑战我们自己人类发展的一个界限。就像我们从材料上来讲，2000多度的炉子。长出材料，怎么去控制2000多度的炉子？我们自己人类从17时代之后，我们就一直在想办法控制炉子，从青铜器的炉子，从钢铁的炉子，一直到今天我们要控制长碳化硅的炉子，怎么样去控制2000多度炉子？这一定是人类技术上最难解决的一些问题。So that's some key difficulties we can share about the silicon carbide industry, how to make perfect materials which suitable for mass production. That's the challenge. Probably we can see many similar challenges in other industry, solar, EV, but I think they probably cannot share the capable experience as we do in silicon carbide industry. That's what happens in our area, GPT, how to make a device. We gonna face a lot of material problems, how to make a reliable device which can capable to undergo such high voltage, such high current impact for always more than 5-10 years. This kind of devices is always the top challenges in the semiconductor. There's some key points about the whole trend, what kind of challenges we're going to face in our industry. So far, we are on half of the way, on half of the road to solve all these problems. so far so good, but I would say the glass is still half the water. The other half of the empty cups is the key for the future of the silicon carbide industry. That's my view. That's my point of view about silicon carbide industry in the world. I would say it's almost the same story for many industries development in the past history, like cars, like EV, like solar. It's all about 0 to 1 and 1 to 99. We are doing the industry. Silicon carbide cannot be contained as a technological problem. It's about mass production problem. So, as what happened in solar, as what happened in EV, as what happened in computer, many other industries, the West are very successful, are very keen to do 0 to 1. But another important thing is you need to do 1 to 99 to make the industry successful in the human development. 0 to 1 innovation, breakthrough, fancy, fashion is always enlightenment for the human development. But all these cherishing accomplishments need to be realized in mass production. So it's almost the same importance as innovation to do 1 to 99. Make everything already happened, keep it as cheaper and cheaper until probably endless cheaper is very important for human development. So today's problem is just about this. China is so successful to do 1 to 99. This success, I think, probably scare the whole politicians in the world. So, why China can success in 1 to 99? I heard about at least 2 big companies, international companies in semiconductor, to do survey in the past 2 years because they are forced by American government to move out of China. So they try very hard to find where to locate their industry for the next 5 years. They try very hard to do surveys in past 2 years. The conclusion is no way. There's no one place can replace China to do mass production in the world. So next China is still China. Why China become China? For my view, it's this fault. You wanted to find another China, you have to find a monetary type of government. Somehow it's tiger model. And the past 30 years of China, we have very successful to copy what happened in Wall Street to do capital. So particularly we learned how to do capital for internet development. When we see PE, the rule of games, we educate a lot of young people to engage capital and VC capitals in China through the internet capital. These are expanding to hard technologies areas in these 2 years. And also China always full of enterprise, full of people try to do more for their own development. And finally, I think for other places of the world, it's very, very hard to build up an army of engineers. And these engineers who can do recipes, to do almost everything from construction, from car tech, R&D, from communications, from software, from hardware. These engineers is the cherishing result of past 30 years China's development. So for why American government or many Western politicians are scared by China? It's just China upgrade the cheap labor into cheap engineers in past 20 years. These cheap engineers, probably this kind of army, they can do 936 and even 811 6. In these days, American workers, they gonna work at $40 an hour. Is unbelievable compared to rest of these engineers here in China. So these 4 conditions, if you want to find another China, try to find anywhere capable to do these 4 points. So for silicon carbide, we are very, if we trace the history, it's hard to say the 0 to 1 happened in America because the history of silicon carbide is the crystal growth, the technology first born in Russia. Many quiz founders, the first one is the technology from Russia, but yes, the America is very important place to do 0-1 in silicon carbide. But at these days, China try to do 1-99 in silicon carbide. This only very part of the picture of what happened in China. Just Mr. Ruan just share what happened in China for silicon carbide. The key is from 1 to 99, always about how to make things cheaper and at very low cost. So as we see here, how to build a fab here in China, the basic cost is like that. And I will say quite in honor about GPT. We can spend about half of this money to build this fab. The day for the GPT, this place you're gonna visit our fab here. We built this fab in 80 million US dollar. 80 million US dollar we can share a fab here in China. And our engineers, a year, we about 6 million US dollar for 996 engineers, residents, engineers, silicon carbide here in GPT. So we are try to do very hard to do 1299 to make silicon carbide can be capable to TK silicon industry. So I'm gonna introduce more about GPT. Yeah, we have a long history to do silicon carbide here in China. We set up our fab in 2012 in Beijing, but it's a very small fab. At that time, we can only do 7,000 wafers a year. In the past 3 years, we use a very limited resource. Just as I said, about $80 million to build a new fab here in this place, Luoyang. We from ground to realize 10,000 wafers manufacture and sales, we make it happen in last 3 years. And we are very honored to engage Chinese market with our products, silicon carbide device. At this moment, we are still the leading ones in China's silicon carbide device providers. And also, we are planning to do 8 inches fab in Beijing in the next year. Still, we probably our budget is less than $10 million. So we are trying to use another benefits of what happened in China. Monitoring government and safety controls and crazy enterprise and restless engineers. Hope we can share our success for the whole silicon carbide industry. And also, I know there's uncertainty years for the future. Very uncertain years. I think what happens for 0 to 1 is very key for the future. China and America create a huge problems for the whole world. The whole world is spending too much, but innovate too less. To do innovations to save the world is very key for the next 10 years. If we lack innovations, if we cannot successful to do 0 to 1, it's not gonna about how much money we're gonna earn for the next 10 years. It's not about peace and war. That's my view. We have very great responsibilities to find a way to do 0 to 1 for silicon carbide industry and for whole other industries. Because yes, China's 1-to-99 capabilities are scaled many politicians in the world. But that's the result created by the whole effort, both from America and China. So that's my views about silicon carbide industry and maybe other industries in the world. Thank you.
Okay, thank you, Dr. Chen Tong, for your introduction of GPT. And Q&A time again. So, any questions?
device sector in China. We have developed a lot of domestic power device companies, and the SPD product now is very cheap, and also GPT's product has been used in BYD. But what happened to our MOSFET products is the production process or the trench patent limitation that limits our MOSFET products in the vehicle use applications. Thank you.
Yes, for the next 2 years, it's going to be, from my view, it's going to be somehow difficult times for silicon carbide industry in China, just because the government and many capitals create so many companies in China. Somehow, if you look outside, if you look at China from outside, you see China is one China. But in fact, China, you can say, at least there's 3 parts of China. The coastline, the midline, and the west. And there's 30 provinces of China. There's 30 provinces. So there's no competitions, very serious and very hard competitions inside China by province to province. So why so many companies coming out in China? It's just because the competition between provinces. Every province try to do silicon carbide. Every province try to create leading silicon carbide companies in China. So they invest. They invest a lot of capabilities that the market is not ready. The market is not ready is just because the material is not ready. The material is still hard to go. The material is expensive. So the problem is for the next 2 years is these companies have a lot of capabilities that the market cannot absorb. So they have to sustain. So they create a very big capable which they can do 20,000 wafers a year, even 40,000 wafers a year. But the market, the whole market cannot absorb. So they have to find a way to sustain for the next 2 years. Waiting for technological breakthrough to make materials cheaper, to make device cheaper and reliable until we can compete to silicon. At this moment, the silicon carbide cost is about, from our company, it's about 5 times higher than silicon. Our real competition is against silicon. So we still need 2 to 3 years to lower our cost at a level we can stimulate our customers to choose more silicon carbide than silicon solution. So next 2 to 3 years is very key for silicon carbide companies.
Okay, that answers my first question. And the second question is the MOSFET device. What's wrong with our MOSFET device? The domestic MOSFET device is not used in vehicles, only the overseas ones. So what happens to our domestic products? Is it in the production process, or the like the raw material, or the trench patent limitation? That's my second question.
I would say for make silicon carbide cheaper, there's a lot of points. Trench is only one point. I always say the key is always material. Sorry, the key is always material. And at this moment, silicon carbide substrates and IPs compared to silicon, there's a lot of space to make it cheaper. For our side, trench is one way to do cheaper, but trench have a very big challenge for reliability, particularly if you want to do vehicle. trenches, you need to be very careful to the solution to choose. Still at this moment, from my observations, many vehicles still can find more confidence to use brand solutions, brand device. But anyway, from our side, we still have a lot of things to do to make silicon carbide more reliable and more cheaper.
I'm Patrick from CNVation. Some years ago, I remember Tesla made a big splash when they decided to use silicon carbide for Model 3. Now, I read that they are not using silicon carbide in the Model Y, the new car. One, is that true? And two, why do you think that is?
I don't have the information very clear, but I think from the basic logic, it should be true. It should be true because still for our customer, even if you are the one to do EV, they always have the choice to do silicon or to do silicon carbide. They always have the choice. So the reason they do silicon carbide is just because the efficient to use silicon carbide is so it's good, but the reliability and the cost of the supply chain create a lot of problems for their plan to use silicon carbide. So again, I think the mask, the Model 3, the mask, Tesla, why they cannot build up the information, they cannot build up the confidence to stick with silicon carbide. It's just because of China. China still needs 3 years to make silicon carbide 1 to 99 successful. If China, if silicon carbide 1 to 99 cannot be successful, the key players in EV, even like Tesla, they will still hesitate, or they will always shift between silicon and silicon carbide. At this moment, the uncertainties about China, whether China can successful to do 1 to 99, is still uncertain. But the trend, the logic is there. We need to do successful in silicon carbide 1 to 99 to make silicon carbide whole production capable to PK with silicon. For my view, 1 to 99 gonna be China. I think ST3 at this moment they are very successful to do the 0 to 1 in silicon carbide. But if they cannot find a way to do 1 to 99, silicon carbide is still a very small industry in the world. The problem is China is already started. It's modern. It's already started to try everything to do silicon carbide to do 1 to 99 successful. If China cannot successful to do 1 to 99, after so big investments in China, they're going to be a great disaster for China's industry ever. But so far, I think I feel more optimistic for China's 1 to 99.
I have mentioned, I have seen a very interesting slide from the previous sharing. You gave 3 stars, rated 3 stars for the design and the packaging, and also 4 stars for the wafer. So is that just like your estimation on GPT's level, or your estimation for the average level for the Chinese silicon carbide enterprise? And because GPT positioned itself as an IDM, right? So there must be some key points you want to make an effort. But which point is that for the design, for the wafer, for the packaging, or we have seen a lot of very powerful enterprise like SMEC and maybe the Huawei and all these big IDMs. They have a strong capability in all these processes. How do GPT form your key advantages in the competition?
Yes. Our GPT's advantage on silicon carbide industry is always focused on innovation. Our innovation is not that fancy in other technological area because for device makers, our innovations are heavily depend on partners. Every innovation happens in GD. We need to rely on what happened on material, what happened on equipment. So it's not innovation we can do wholly content inside GPT. We need to find a partner for any improvement for our performance of the device. Every movement we try to do something new, we will find somebody can do equipment to make some sort of equipment or improve the equipment we have. We cannot build equipment ourselves. We cannot even improve equipment ourselves. And for a fact, there are so many points, so many equipments we need to integrate to make devices happen. So that's the key. So first, it's open. GPT is one advantage in here. As you said, the Huawei and many other companies, firstly, GPT is very open. We can share a lot of things to do cooperation with material companies, with equipment companies. The first thing is open. Probably it's because of the nature of the GPT. We have the genes for self-development. So we know our disadvantage. So they force us to be more open. So that's the first advantage. The second advantage is innovation is about a fact. Particularly for silicon carbide industry, we call innovations, but on the other hand, let's try. I don't know. 试错在英文里面该怎么翻译比较好
？Trial and error.
Trial and error. 试错。Every innovation is about trying something you don't know. So you need to be prepared fair to do innovation. I think that's the biggest advantage here in GPT. Our problem is we grow up from a very private small companies. We don't have a lot of resource, like a lot of government funding companies. They have a lot of huge money to buy this, buy that. They can buy a lot of equipment and try it, but we can't. So in the circumstance, so little resource we have, but we need to try so many things we know probably gonna be fail. That pressure is the pressures and the goal is our advantage. So for innovation, trying everything you probably know it's a way to be fail. You spend a lot of money, probably you just throw into the water. That kind of pressure you can undergo is one very key advantage for silicon carbide.
Okay, thank you, Dr. Chen Tong.